In this part 1 of the video, I am going to describe an experiment which can be easily conducted at home. The experiment is primarily based on Archimedes Principle. What you see in the figure is a jar half full of water. It is resting on a weighing machine. The weight of the jar along with the water is recorded in the reading W1 of the weighing machine. What you also see a cylindrical body hung by a spring balance in the jar, and the body is not touching the walls of the jar or the water level. The reading of the spring balance is recorded in W2, and we are interested what will happen to these readings W1 and W2 as we progressively dip the body into the water. Firstly, we'll dip it partly into the water as you see in the figure. The W1 and W2 will change, and we want to know what the changes will occur. And if we dip it further so that the full body is immersed into the water, will the W1 and W2 further change? And further, if we dip it further so that the body does not even now touch the bottom of the vessel, will W1 and W2 further change, still change? Finally, the body rests on the bottom of the vessel, and we are interested in knowing what happens to W1 and W2. And the second part of this video, I am going to talk about the physics principles which will go so that we can arrive at the right conclusion how W1 and W2 will change. So in this part of the video, we are going to talk about the physical principles which will determine how the readings W1 of the weighing machine and W2 of the spring balance change as the experiment proceeds through the 4 stages of immersing the body into the liquid. Of course, the first thing we must know about this is what is mass and what is weight of a body. We know that the spring balance measures the weight. The weighing machine measures the weight. Mass is the property of the matter, while weight is the force with which a body is attracted toward the earth. So how do we measure the mass then? The mass is measured using a beam balance. So if you want to differentiate between mass and weight, you will know that the weight of the body will decrease as we go up, say for example on the top of Himalaya, or down into the earth, say 1 kilometer below the surface of the earth. But the mass of the body will not change. So if you take a spring balance, measure the weight of the body at Everest, and it will be less because of the less force exerted due to the acceleration due to gravity at the top of Himalayas. But if you measure the mass of the body using a beam balance, you will find that the mass will remain same whether you measure it on the surface of earth or on the top of Everest or 1 kilometer inside the ground. So that is the difference between mass and weight of a body. And here we are all the time talking about only weight. Then, since we are talking about taking the body inside the liquid, what happens when a body goes inside the liquid? The liquid exerts a pressure on the body. Actually, a liquid, inside the liquid, at any point in the liquid, a pressure is exerted in all the directions. What is pressure? Pressure is nothing but force divided by area. In liquid, it increases as the depth increases and is always normal to the surface. It is proportional to the depth and it is always normal to the surface. So pressure is a scalar quantity while force is a vector quantity. So if you understand what is a scalar quantity and vector quantity, this is a good example. Pressure is a scalar quantity and force is a vector quantity. The law which is to be applied here are Newton's laws of motion. Do we have to apply all the laws? For completion's sake, I will say what the Newton's first law of motion is that every body continues to remain in a state of rest or state of uniform speed until an external force is applied on the body. The Newton's second law is rate of change of velocity of a body is proportional to the applied force. But these two laws need not be applied here. What we need to apply here is Newton's third law of motion, which says for every action there is an equal and opposite reaction. And then, of course, there is this Archimedes Principle. The Archimedes Principle states that when a body is immersed into the liquid, its weight decreases, and the decrease in weight is equal to the amount of water the body displays. So these are the principles which we need to be applied. So let me repeat these Newton's laws. Newton's first law of motion says an object at rest or if in motion remains in motion at constant velocity unless acted on by an external force. Newton's second law says that the net rate of change of momentum of a body is directly proportional to the net is an important word, net external force applied to the body, and this change in momentum is in the direction of the force applied. The net force on a body is equal to its mass times acceleration. That is, force is equal to mass into acceleration. But these two laws are not required for explanation in this particular experiment. What is required is Newton's third law. If an object A exerts a force on an object B, then object B must exert a force of equal magnitude and in opposite direction back on the object A. What is to be remembered here is, which is not stated in the law but is implied, that both the forces act simultaneously. This is often forgotten in definitions of Newton's third law of motion. And then, of course, the Archimedes principle in so many words. When the object is partially or completely immersed in a fluid means either gas or liquid, the object experiences an upward force called buoyancy that is equal to the weight of the fluid displaced by the object. So, with this in our background, we will be now answering the questions which were raised for conducting the experiment. Let us start the third part of the video. In this part, we are going to explain what are the observations we expect when we conduct this experiment based on the principles of physics which we learned in the second part of the video. So initially, when the body is in air without touching the walls or water, the spring balance reading will record the weight of the body. While the weighing machine reading, that is W1, will record the weight of the jar or say tub containing water. Now we dip this body partly into the water. Now what happens? The body is going to displace some water. So Archimedes principle has to be applied. And second thing is, because now body is in water, there will be two types of pressures acting on it. The first pressure will be lateral pressure on the cylindrical body, which will be acting normally to the surface, and the second will be pressure acting normally upwards on the bottom surface of the body. The lateral pressure, when converted into force, will cancel out each other, and there will be no net lateral force. While the force on the bottom surface is going to create a net force upwards, which will be leading to reducing the weight of the body, and thus the recording on the spring balance will show a decrease in the weight. But now, according to Newton's third law of motion, this upward force will have a reaction. The body will exert an equal amount of force downwards, and this downward force will be reflected in the reading of the weighing machine. So the weighing machine will record in W1, whatever is recorded in W1 will increase. So we must notice that increase in W1 will be equal to decrease in W2, and that will be equal to the weight of the volume of the water displaced by the body. If we immerse it completely, the similar thing holds, but now the body is going to displace much more water, and so the W1, the reading of the weighing machine, will increase further, and W2, the reading on the spring balance, will decrease further. But increase in weight, increase in W1 will be equal to decrease in W2 is equal to weight of the water displaced by the body, that is weight of water which has a volume equal to the volume of the body. If we immerse it further without touching any walls, only touching walls, without touching the bottom and without touching the walls of the tub, we notice that the amount of water displaced by the body is going to remain same, and so nothing changes. So if it is not touching the bottom, then W1 will remain same and W2 will remain same, because nothing has changed. It is displacing the same amount of water. Now we leave it onto the bottom. Now what happens? Now the spring balance is not going to feel any weight because of that thread is loose now. The full body weight is being experienced by the platform of the weighing machine, and so W1 will record the weight of the tub plus weight of the water plus weight of the body, while W2 will record no reading, because we are not able to, the body is not able to transfer any weight to the spring balance, because the thread is now loose, because the body is resting on the platform. Now you should conduct this experiment and check whether our reasoning is right or wrong. And now, if you have understood this, I have two questions to you. Supposing right in the beginning, whatever is the water level, we make a hole in the jar just above the water level. And as the body dips into the water overflows comes out through the hole. And when the body is totally immersed without touching any walls or bottom of the weighing machine, how the readings on W1 and W2 will change. And second question, if you have understood it well, please try to answer. If I have a brick, it has something to do when Archimedes realized how he has to find out how much gold and silver is there in the crown which was offered to him to find out the relative composition. So if I have a brick made of silver and gold, how will I find how much of it is silver and how much of it is gold? Kindly rate this answers yourself also, and later on I'll tell you the correct conduct the experiment and check. Thank you so much.